The publisher of a new magazine gathered data from potential subscribers about their age and the price they would be willing to pay for a 2-year subscription. He used a graphing tool to organize the data in a scatter plot and find the line of best fit. He found that the relationship between a person's age and the price X, person's age X and the price Y is modeled by the equation Y equals 0.981X minus 1.714, and the correlation coefficient for that data is 0.237. Could this line of best fit be used to make a reliable prediction about the price of a potential subscriber is willing to pay? The part that we really need to look at on this is the correlation coefficient. And the thing about the correlation coefficient is the closer that the value is to 1, the more accurate that the prediction equation is going to be. And in this case, our correlation coefficient is 0.237, which is not very close to 1. And consequently, as we look down there, it's definitely not going to be yes. And our two choices then are no, because the slope of the line of the best fit is closer to 1 than to 0. Nope, it's no, because the correlation coefficient is closer to 0 than 1, which indicates a weak association between the variables. A similar problem in here, and actually there's 3 of them. A botanist gathered data about the number of pine, oak, and birch trees found in local parks. He used a graphing tool to organize his data in different scatter plots and found the following lines of best fit. The relationship between the number of pine trees X and oak trees Y is modeled by the equation Y equals 0.92X plus 2.14, and the correlation coefficient for the data is 0.664. The relationship between the number of birch trees X and the oak trees Y is modeled by the equation Y equals 0.73X plus 1.13, and the correlation coefficient for the data is 0.939. The relationship between the number of birch trees X and pine trees Y is modeled by the equation Y equals 0.88X plus 5.12, and the correlation coefficient for the data is 0.813. And it says, which line of best fit can the botanist expect to produce the most reliable predictions? Well, we're going to look at the correlation coefficients, and the 3 of them are 0.664, 0.939, and 0.813. We want the value that is closest to 1, which is 0.939. And as we look at that, then what we're looking at is the birch trees and the oak trees, which is going to be this choice right here. One more similar problem on this topic here with respect to correlation coefficients. Charlie gathered data about the time it takes him to complete a crossword puzzle and the number of clues in the puzzle. He used a graphing tool to organize the data in a scatter plot and find the line of best fit. He found the relationship between the number of clues X and the time required to complete the puzzle Y is modeled by the equation Y equals 0.376X plus 15.48, and the correlation coefficient for the data is 0.219. Could the line of best fit be used to make reliable predictions about the time it takes Charlie to complete a crossword puzzle? Again, we're looking at the correlation coefficient. Because it's 0.219, that value is closer to 0 than it is to 1. Let me repeat that the closer that the correlation coefficient is to 1, the more accurate our prediction equation will be. So it's going to be one of the no answers again. And in fact, it is the bottom one, same exact answers. No, because the correlation coefficient is closer to 0 than 1, which indicates a weak association between the variables.